A diffraction grating actually works like light passes through a lots of slit. So diffraction occurs, then interference occurs among the lights, then maxima and minima are produced due to the interference. Now let's solve this question. Look at this. In an experiment, laser light is shown through a diffraction grating so that a series of bright dots appear on a screen. The equation, they gave this equation, n lambda equal to d sine theta, can be used to determine the wavelength of the laser light. Now look at this one. Actually, this is the laser source. So from this laser source, laser light moving in this direction, and there is a diffraction grating in here, a diffraction grating, and lots of slit is in there, then parallel to this diffraction grating there is a screen. In this screen initially a zero order maxima is formed. In here a zero order maxima is formed, then another maxima is formed. This is first order maxima, this is second order maxima. In the same time another first order maxima is formed in here, another maxima is also formed in here. Is it clear? Now actually interference occurs, destructive constructive interference occurs. So in here the equation n lambda equal to d sine theta. So what is represented by this actually? This lambda is the wavelength, the ray which is used in here, and d, that is the distance between two slits. This is d, distance between two slits, that is d. Okay, now the first one, as they told, the angle theta is measured using a protector. This is not the correct answer. So why? What's the reason behind this? Because theta is calculated by taking the measurement of the diffraction grating to screen distance and the distance between bright dots. Then we just have to using trigonometry, so that way easily we can determine the theta. And second one, the diffraction grating is set up so that it is parallel to the laser light beam. So look at this one. In here this laser light is not parallel to the diffraction grating. This laser light is perpendicular to the diffraction grating. Laser light is the perpendicular. This laser light is perpendicular to the diffraction grating. So B is not the correct answer. And third one, the diffraction grating is set up so that it is parallel to the screen. Ultimately, yeah, this is the diffraction grating and that is the screen. So ultimately these two are parallel to one another. So this is the correct answer. And the last one, the distance between the bright dot is measured with a micrometer. Actually for diffraction grating this is not the correct answer, as distance between the bright dot is best measured using a meter rule. We can easily use a meter rule, so micrometer is not needed. So ultimately the correct answer is C. So let's solve this question. This question is a diffraction grating has 300 lines. Careful, 300 lines per millimeter. So when laser light is directed towards the diffraction grating, a diffraction pattern is observed on the screen. The position of first order maximum. So this is another clue for us. First order maximum on the screen is shown on the diagram. So there is some information. This is laser light diffraction grating. This is 2 meter and this one is 0.4 meter. This is first order maxima. Now the question is, which of the following calculations should be used to determine the wavelength in millimeter to the laser light used? So you know that n lambda equal to d sine theta. So they asked about the wavelength. We just have to calculate the lambda. So in here n, what's the meaning of this n? So this is first order maximum. First order maximum means the value of the n is 1. The value of the n is 1. Then we just have to find out the value of d, and d is, there's information in here. This is 300 lines per millimeter. 300 lines per millimeter. So how to calculate the d? So 300 lines per millimeter. So 300 lines in 1 millimeter. So ultimately 1 lines in 1 by 300 millimeter. We just have to calculate this one. So 1 by 300 lines per millimeter. So d equal to 1 by 300. And we need another things, that is the value of theta. So how to calculate the value of theta? So this one, look at this one in here. If I make it as a triangle, like this is the triangle, so we just have to calculate this theta. The value of this adjacent is given, this is 2 meter, and the value of this opposite, that is 0.4 meter, this is 2 meters. So ultimately how to calculate this theta? O by A, that is 10 theta. So we know that 10 theta equal to O by A, as 10 theta equal to opposite by adjacent, O by A. So 0.4 divided by 2, that is 10 theta. So theta would be 10 inverse 0.4 divided by 2, as now we have the all of the information in here. So ultimately D is the correct answer. This question, the teacher made the following measurement. Distance from the central maximum to first order maximum is given. Distance from diffraction grating to screen, that one is given. The wavelength of the light is given. So ultimately the diagram, this is the laser, so this is the diffraction grating, and this is the screen. And for this diagram they gave this distance, the distance from, this is central maxima, and this one is first order maxima, and this distance is given, this is 1.61 meter. And distance from diffraction grating to screen, this distance is given, this distance is 2.74 meter. So from these two information easily we can calculate the angle, that this is 2.74, that is 1.61. So ultimately 10 theta, we know that 10 theta equal to O by A, okay, opposite by adjacent. So ultimately in here opposite, that is 1.61, adjacent 2.74. so this, from this calculation, theta equal to 30.4 degree. So what other extra information is given in here? So as we know that n lambda equal to d sine theta, so you just have to calculate d. So d equal to n lambda divided by sine theta. So in here, as value of the n, that is 1, and lambda they just gave it, this is 532 nanometer. We just have to convert it into meter, so 10 to the power minus 9, and sine theta, sine 30.4. so the value would be 1.05 into 10 to the power minus 6 meter. This is the distance. Okay, so the number of lines per meter, that one would be 1 divided by 1.05 into 10 to the power minus 6. Okay, so this information is line per meter, that is 9.52 into 10 to the power 5 per meter, but they are asking per millimeter, so you just have to convert this meter into millimeter. So number of lines per millimeter, number of lines per millimeter would be 952. That will be the answer. So the answer is 952 lines per millimeter.